Okay, we're going to talk about solving equations, and this is the basics of solving equations. So we're going to use inverse operations. So that's opposite operations that undo each other. So use inverse operations to move things from one side of the equation to the other. So if you have an equation, you might need to use inverse operations. If you have an expression, you're not going to use inverse operations. We'll talk about that in a minute. So in this first example, the inverse of addition is subtraction. So we're going to subtract 2 here to try and get x by itself. If I subtract 2 on one side, I need to subtract 2 on the other side. Again, the reason we use inverse operations is this gives us 0 on this side, which means it's not there anymore, which gets me x by itself, which is what I want. 5 minus 2 is 3, so x equals 3. If you plug that into the original equation, you can check and see if it works. Okay. Let's talk about the inverse of subtraction. That's going to be addition. So currently we're subtracting the 2, so we're going to add it. Again, if you add something to one side, you add it to the other. So we get 7 equals x. Again, you can plug that back in and check and make sure that it works. Okay, the inverse of multiplication is division. So currently this 2 times x is how we would read that. 2 squeezed next to x means multiplication. So in order to undo that, I'm going to divide. Divide by 2, divide by 2. Again, whatever you do to one side, you must do to the other to keep the balance. So 5 equals x. You can plug that into your original and you can make sure that it works. The inverse of division is multiplication. So here I'm dividing by 2, so I need to multiply by 2 to make it go away. Again, 2 divided by 2 would be 1, and 1 times x is just x, so that's why that works. So over here we multiply by 2, 20 equals x. Again, plug that back into your original and make sure that it works. Okay, the next part is solving multi-step equation. So you're going to use inverse operations to isolate the variable. So isolate means to get it alone. So whichever variable you're solving for, you want to get by itself. So in our first example, we're trying to solve for x. So the first step would be to, First step would be to add 7. Add 7 to the left, or to the right. So you add it to the left. 10 equals 2x. Now the inverse operation of multiplication is division. Divide, divide. X equals 5. Can plug that back into the original and check it out. For the next example, now we're solving for y. So again, inverse operation of addition first. So we're going to subtract 6. Subtract 6. 4 minus 6 is negative 2 equals y over 3. Now we need to multiply by 3 to get rid of it. Multiply by 3 over here. Negative 6 equals y. Last example over here. Doesn't really matter that we've got more going on the left on this equation. We're still going to move everything away from the z. So now we're going to subtract 7. Subtract 7. 3z equals 6. Divide by 3. Divide by 3. Z equals 2. Okay. Next part of this is like terms. Like terms are terms. And terms are separated by addition or subtraction if you're looking at an equation, whose variables and their exponents are the same. So when we look at this list here, I'm looking for constants. Those are just numbers. I see that I have some x terms, some x squared, some y squared. So that's really what I'm looking for. So the only number I see is this 5 right here. So that's a constant. It has no like terms in this list. So now if we look over to the x terms, we have 5x's, 4x's, and negative 5x's. So we would have 5x is a like term of 4x and of negative 5x. Those are all like terms. So now we're going to look for our x squared terms. 2x squared, negative 5x squared, 8x squared. 2x squared, negative 5x squared, and 8x squared. Again, notice it's all about the variable and the variable's exponent. So this is all about the x squared terms. Now we're going to look at our y terms. We have 3y's, 6y's, and negative 7y's. So 3y, negative 7y, and 6y are my like terms. Last but not least, my y squared, 6y squared, 4y squared. 6y squared and 4y squared are my like terms there. So again, exact same variable relationship, and if it's squared or cubed or to the fourth or whatever, that's what you need to consider a like term. Okay, now we're going to simplify expressions by combining like terms. So there's no equal sign in these expressions, so we are not using inverse operations. We're just combining like terms. So I see my 2x squared here, and I do not see another term that has an x squared. So 2x squared is all by itself. It's just going to stay there. My next term is negative 2x, and I see these 9x's over here. The operation, in this case subtraction, always goes with the guy behind it. So this we would consider negative 2x's. Negative 2x plus 9x is 7x. And then this 4y doesn't have any buddies either, so it's just plus 4y over here. Okay, now we have two like terms with our x squared, negative 4x squared, negative 8x squared, and then my 3x is all by itself. So when I take 4, you owe me $4, you borrow 8 more, now you owe me $12, and then we just have plus our 3x because he has no buddies. Okay, in this next example, we have 3xy and negative 6xy. Again, this has the same exact variable relationship. It happens to have two variables, an x and a y, but they're the same, so we can combine them. 3xy minus 6xy would be negative 3xy plus 7y squared. He has no buddies, so he stays the same. Okay, in my last example here, I have 3 and negative 8. These are constants. I can combine them. That would be a total of negative 5. And then I also have my 5x's and my negative 9x's. 5x minus 9x is negative 4x. Again, we can't simplify any of those any further because we can only combine the like terms.